Hi everyone, it's Mr. Campagna. Today I'm going to show you step by step how to use the simulation as seen in today's lesson. So in a previous lesson we learned about how radium decays into radon and a helium atom. And that high energy helium atom, also known as an alpha particle, is radiation. So it's radiating away from the radium atom. So if you skip ahead a few slides, you'll see the link to the simulation. So just click the link and you'll be brought to the site. Radiation Detection Lab. In this lab, you'll be looking at the amount of radiation you detect from a radioactive source based on the distance between the detector and the source. When you're ready to start the lab, click the Begin button. Now you'll notice immediately the radioactive sample is giving off alpha particles. Now, you can't see these things in real life. Alpha particles are invisible, but the detector can. And again, that's why we have the detector. If you'll notice here, you have a couple of things. We have a timer, which is running. We have our probe, which is attached to our detector. You can see the rate of detections appears to be increasing. And as we pull the probe away, you'll notice that the rate of detections are decreasing. Now, if you want to get a specific number, as I was moving the probe during that 60 seconds, so this number would not be accurate for this height. So we might want to reset. So you'll notice when I click this, the timer begins again. At 323 millimeters, over the course of, let's say, 15 seconds, now, I didn't get it exactly on 15 seconds, but it was pretty close. You could see that I had 13 hits or 13 counts of alpha particles hitting the probe. And again, we're really only talking about it hitting this one little small area right here. Now, if we move the probe down again, you can move it to whichever height you want, and then you hit reset, you'll notice that it begins again from 0, and the counter was cleared out. Independent work. Procedure. 1. Go to Physics Avery Radiation Detection. You can click through to get directly to the site. Click Begin. Move the detector to the lowest possible distance from the source by clicking the down arrow. Let's do that. Click Begin. Move it to the lowest position. In your data table, record the distance. Now I've noticed these distances are different each time you reload the simulation, so your results will probably be different from mine. So here I'm going to add 61 millimeters for my distance. Next it says click on Reset. Start watching the timer. After 10 seconds, click Hold. No need to get exactly 10 seconds. Do your best. Click Reset for a do-over. So first we're going to click Reset. We'll watch the timer, and after 10 seconds, we'll hit Hold. Now, just so I'm not giving you the answers, I'm going to go up to 20 seconds for mine. So let's hit Reset, and I'm going to click Hold when it hits 20 seconds. 19, 20. All right, not too bad. I was trying to get 20.00. So you're not going to be exactly perfect on this, but on my lowest count, I got 251, so 251 counts. Next it says, in your data table, record the number on the counter. This is the number of alpha particles that hit the detector in the 10-second time interval. Move the detector up. Click the up arrow once to the next distance from the source. Repeat steps 4 through 8 until your data table is full. Click up once. Click Reset. Again, I'm going to wait till 20 seconds, but you're going to stop at 10. So this time the counter registered 155 counts, or 155 alpha particle interactions. So we're at 94 millimeters, 155. Let's move it up another click. Let's click reset. Again, you're going to click hold at 10 seconds. I'm going to 20. That was pretty close. All right, so we're 118 millimeters and 88 counts. Let's move it up again. Let's click reset. Okay, so this time around it was 156 millimeters and 69 counts. 156, 69. Let's move it up again. Click reset. This time it was 179 and 52. Let's move it up again. Click reset. Here we have 205 millimeters and 36 counts. Let's move it up again. Click reset. This time it was 247 millimeters and 17 counts. Let's move it up again. Click reset. 277 and 17. Let's move it up another click and click reset. 309 and 22. So let me be clear. This table will look different than the one that you will collect. I was collecting them over 20-second time periods. You need to collect them over 10-second time periods. Also, your distances will be different because the simulation does assign different distances each time you load it up. So you're going to need to keep this data handy. Tomorrow, you are going to graph your data and draw more formal conclusions. So for today, what do you notice from your data? So you will be graphing your data and drawing conclusions in the next part of this investigation. What do you need to remember about this part in order to be successful in the next part? So this simulation really isn't all that difficult. I think the biggest thing is when you hit the reset button, the timer immediately starts back up, which can be a little bit confusing at first. Just remember to hit that whole button right at the 10-second mark, record the height the probe is, and the number of counts. I hope this was helpful. Thanks for watching.